Alright people, welcome back to the next lesson, and as I said in the last lesson, we are going to look at conversions. So if I go back to my document, which we ended there the last time, we're going to be on this chart here. Now people, I find that over the years, a lot of people say, yes, I can convert, I know how to convert, blah blah blah, they know, but when they get to this class, then they learn that a lot of you don't actually really know. Okay. So I've taken the metric conversion chart there, which looks like that. And there's the basic unit. Remember the basic unit? I refer to the basic unit there. There's the basic unit or the base unit. Okay. And there I've written there below there. If you can print it out or do the same, good for you. So the basic units are meters, okay, for distance, kilogram for mass, and liters for volume. Okay. So that's distance, mass, and that's volume. Okay. Right, so people, so that's the base units. Now, a lot of people know what they need to do, but they just never quite get this correct. Okay. Now, if you look at this top of this here, okay, if I go to the left here, if I'm looking at distance only, that will be kilometers, hectometers, decameters. These two we hardly use, but it's there. And then we have meters, decimeters, which we don't often use. And then we have centimeters and millimeters. Okay. So the most commonly ones used is kilo, centi, and milli. Okay. For us as civil engineers. Now, this at the top here, this block here, and that block there. Okay. What it means is that, okay, when we convert from a big unit to a tiny unit. Now, okay, deci, centi, milli is all smaller units. Okay. When we convert from meters to deci, centi, milli, we must, can you see that word there? A lot of people can just never quite get this, and I find that even people who get up to third, fourth year, they can never understand why they need to do this, and they get it wrong. Okay. Now let me make this a bit smaller here. When you convert from a big unit to a smaller unit, you must multiply. Multiply. I'm going to put a nice fat exclamation mark there. Okay. So, if you're converting from meters to millimeters, you must multiply by. Now remember, that's 1, 2, 3. So, to convert there, you must multiply by 1,000. To convert from meters to centimeters, you must multiply by 1, 2 by 100 by, you must make it 100 times bigger. Okay. And if you're converting from meters to decimeters, you must multiply by 10. That's it. Okay. So that's 1 space, that's 2 spaces, that's 3 spaces. So that's times 10 times 100 times 1,000. Okay. If we must convert meters to kilometers, okay, sorry about that, we must divide. So if you're converting from a small unit to a bigger unit, we must, so here, going from meters to kilometers, we must divide by 1,000. This doesn't want to work so well, this, man. Okay. And if we must convert from meters to hectometers, that means from a small unit to a big unit, we must divide by 100. And here we must divide by, yes, you got it, by 10. Okay. So, if we're converting from kilometers to millimeters, what do? First of all, when we go from left to right, we multiply by, but we multiply by 1, 2, 3, 4, 5, 6. So going from kilometers to millimeters, we must multiply by 1 million. That's right. Or you multiply by 10 to the power 6. Did you get that? I'll say it again. To convert from kilometers to millimeters, we must multiply by 1 million or multiply by 10 to the power 6. Multiply. Okay. If we must convert from millimeters to kilometers, we're going to the left, we must divide by 1 million or divide by 10 to the power 6, and so on. Is it working? Are you getting there? Right. So if we must convert from kilograms to centigrams, what do? we must multiply by 100. Okay, so 1 kilogram is equal to 100 centigrams. To convert from kilograms to milligrams, we must multiply by 1,000. Okay, right. So to convert from centigrams to kilograms, what do? We must divide by 1, 2, 3, 4, 5. That means from centigrams to kilograms, we must divide by 10 to the power 5 or multiply by 10 to the power minus 5. Did you get that? Okay. So from centigrams to kilograms, we must divide by 10 to the power 5. Okay. So people, once again, to go from a big unit to a small unit, you multiply by so many that you need to go. If you're going from a big unit, so if you're going from a smaller unit to a bigger unit, you must multiply by, that's 1,000, 110, and so on. But kilo and centi and milli is the ones we normally use. Okay, whether it's meters, kilograms, or liters. Right, people, there's the first exercise. Okay, for example, so if we must convert from 2,000 milligrams to grams, okay, is that going from big to small? That's going from small to big. We're going from milligrams to grams. So that means we must divide by 1, 2, 3, divide by 1,000. So that's going to be 2 grams. Can you see that? Okay, that's how we do that. So to go from milligrams to grams, we're going from a small unit to a big unit, we must divide, okay, and from grams to milligrams, from milligrams to grams, okay, it'll be 1, 2, 3, to be 1,000, so it's 2,000 divided by 1,000, so it'll be 2 grams. So 2,000 milligrams is equal to 2 grams. And you do the same for liters. To go from liters to milliliters, we're going from a bigger unit to a smaller unit. We're going from liters to milliliters there. Okay, so we must multiply by 1,000. So that'll be 5. Oh, the writing doesn't like it. So 5 liters is 5,000 milliliters. I'm going to do the next one. Centimeters to millimeters is from a big unit to a small unit. It's from there to there. Okay, and how many places? We must go 10. So 16 centimeters is equal to, we must multiply by 10, so it's 160 millimeters, and so on and so on. Okay, so you first establish, is it times or divide? Then you establish how many places do I need to go up or down. Okay, and then you do the calculation and you write in the answer. Okay, people, normally when I give exercises, I give the answers, but I don't give them for this, because if I give you the answer, it's job done. You don't need to do anything. Okay, but for everything else I give you, I'll always give you the answers, or 99% of the answers. Right, people? So finish all of that off. And I'm reminding you of what I said to you in the introduction. Do all the problems I said to you. So work through the whole worksheet, okay? Do all of them. Work all of that there. But the next one here, it says compare using less than, greater than, or equal to. Okay, so what you need to do, you need to convert the one to the other one. So if you convert centimeters to that there, if you convert that to meters, okay, and then you can see there whether that is greater or less than. Okay, convert the one to the other one, you compare the two. Okay, I'll say it again. You convert the one to the other one, you compare the two, and see whether the one is greater than, whether that's greater than that, whether that is less than that, or whether that is equal to that. You do it for those 6 over there. Okay, and you compare answers with your friends. Okay, if you're working together, compare with answers with your friends and see what you get. If you get the same answers, most probably you got it correct. Okay, do all the problems I said to you. Right, I'm going on to the next one. Right, people, convert. Now just a note here. Notice that that's 10,870 grams. It looks like this. Okay, it's 10. You can write it like that as well. Okay, so the comma there, people, the comma is a separator, it's the thousandths separator. So that's 10,870 grams, and you need to convert that to kilograms. Okay, kilograms. Okay, kilograms. So you must first do one of two things. You must first see whether it's going from small to big. So do we multiply or we divide? We're going from a small into bigger, so we must divide. Divide by how much? Divide by 1,000. So it will be 10,870 divided by 1,000, which just means the decimal point is sitting over there. So I move the decimal point 1, 2, 3. So it's 10.87 kilograms. So that's your answer. Okay. So the comma is a thousandths separator, and then that dot there is 0.7 kilograms. Okay. That's the decimal point. The comma is a thousandths separator. Okay. You need to zoom in a bit. I know it's a bit fuzzy, but that's a comma, that's a dot. Okay, that's a dot. So that's 25.3 kilograms. That means going from a big to a small, I must multiply by 1,000. So the answer would there be 25,300 grams. Ne? 25,300 grams. This is 17,000, and it's the 17,934 grams. You must convert it to kilogram. So that's 17,000. So that's 17,934.00 grams divided by 1,000, because we're going from a small unit to a big unit, and so on and so on. Do all of them. Do all of them. Okay. So that there is the decimal point. That there is a thousand separator. Do all of them, even if you know all of them. If you know all of them, you'll finish this off like in 10 minutes. Okay. Work through all of that, and work through all of that as well there. So that's all mass. This here is all distance and volume. Do all of them. Okay. I'm going down the sheet. That's page 5. Right. Scientific and engineering notation. Alright. Scientific and engineering notation works like this. Let me just clean the board quickly here. Right, people, when we have a very tiny number or very big number, we usually write it in an exponential notation. Okay. But if the number looks like this, for example, 6.58 times 10 to the power minus 6, let's call it meters. Okay. When the number is written like this with one whole number there, there's one whole number there, followed by the dot or the decimal point, followed by 1, 2, 3, or how many numbers there are, times 10. This here, we call this exponential notation. Exponential notation. Okay. So if, I'll say it again, if we have a number followed by the dot and 1, 2, or 3 numbers, no matter how many you have there, times 10 to the power, it could be plus 6 or minus 6 or plus 7 or whatever, followed by exponential notation. That whole number there, we call that scientific notation. Okay, we call that scientific notation. If a number looks like this, 62.847 times 10 to the power, let's say 12. Okay, let's call that watts. Okay, if we have a number, whether it's 1, 2, 3, okay, or 4 numbers there followed by the dot, okay, followed by how many numbers there are after the decimal, and we have an exponential notation like this there, and that number there is in multiples of 3. It could be 3, it could be 6, 9, 12, 15, 18, like we said earlier in a document up there. Remember we spoke about this there? That is why we have this like this, because they have names for it. Okay, so if it's 3, 6, 9, 12, or minus 6, minus 12, etc., etc. Okay, if it's like that there, then this here will be what we call engineering notation. Let me just change the color here. This here is scientific notation. And this here is engineering notation. Notation. There we go. Okay. Now, if I write this number, now this number, you check this number out here. Is this number also in engineering notation? Yes, it is. It just happens to be in engineering and scientific notation as well. Can you see that? Okay. So if I write this number like this here, 6.2847 times 10 to the power, if I make this number smaller, I'm going to make this number bigger. Just by the way, is that number equal to that number there? Yes, it is. Okay. I made this number 10 times smaller. That means I need to make its exponent 10 times bigger. So 62.847 times 10 to the power 12 is equal to 6.2847 times 10 to the power 13. Okay. This number here, is this number in engineering notation? No, it's not. But it is in scientific notation. Are you getting that? Okay. So this number here, so scientific notation is a number, one number followed by the decimal, by however numbers there are there, times 10 to the power. Okay. That could be -1, it could be -2, it could be -7, it could be 8, it could be 14, it could be 27, it could be 30. That will be scientific notation. But if it's written with 1 or 2 or 3 numbers followed by the dot, followed by a number of numbers, however it may be, okay, and the exponent here is in multiples of 3, it will be in engineering notation. Okay, but this number here and that number here, because that's in -6 there, this particular number happens to be in scientific as well as engineering notation. Okay, right. So that's the explanation of scientific and engineering notation. Right, I'm going to clean the board and we're going to look at a few examples. Right. There's my, where are we? There we go. It says convert each ordinary number to scientific notation. Let me just, there we go. So that's going to be, let me just see, 1, 2, 3, 4, 1, 2, 3, 4, 5. Let's do that. Okay. So 0.0. Three, 4, 5, 9, 5. Right. Write it in scientific notation. So what I'm going to do, I'm going to move the decimal point to that over there. Okay. Scientific notation. One number followed by the decimal. Okay. Multiplied by. Now, if I said this. Okay. Okay. Is that equal to that? Of course it can't be. Okay. 0.000095 is a very tiny number. That's a bigger number. So that is not equal to that. So I need to write it in proper notation. So I say times 10 to the power. So I made this number 1, 1, 2, 3, 4, 5, 6. I've made this number 6 digits bigger. So I must make it 6 digits smaller. There we go. So that number is in ordinary notation and that number is in scientific notation. Okay. Is that number in engineering notation also? Yes, it is, because its exponent is in multiples of 3. So that number is scientific notation and it just happens to be in engineering notation as well. Okay. Right. Let's do the next one. I'm going to take that one there. 1, 2, 3, 4, 5, 6, 7, 6, 5. Let's do that one. So let's see. So it's 0.1, 2, 3, 4, 5, 6, 7, 6, 5. Write it in scientific notation. I move the decimal point up to the next to the first number there, so it will be 7.65 multiplied by, right, let's see, I made it 1, 2, 3, 4, 5, okay, 1, 2, 3, 4, 5, oh man, 1, 2, 3, 4, 5, 6, 7. So it's times 10. So I made this number 7 places bigger. So I must make it 7 places smaller. So that number, which is the ordinary number, I now wrote it in scientific notation. Is that number engineering notation? No, it is not engineering notation. Right. Write that number in engineering notation. Right. Think about it. Think about it. Okay. Think about it. Write that number in engineering notation. See what you get. Now, I need to move this decimal point either left or right to make that either -9 or -12 or -6 or -3. But remember, scientific and engineering notation has numbers in front of the decimal. Okay, so what I'm going to do, if I move this decimal point 1, okay, I can't go this way because it's going to be 0.7, and that's not correct notation. So I'm going to go that way. So if I move this decimal point there, okay, so if I make this one bigger, 76.5, that's going to become, if I make that one position bigger, that's going to become one position smaller. So what it's going to be if I make it smaller? It's going to be, think about it. What will it be? Right, if I make that number, if I make this number 10 times bigger, that's going to be 10 times smaller. So what's that going to be? Is it going to be -8 or -6? If I make it smaller, it's going to be -8. Okay, so is that engineering notation? No, it is not engineering notation because that's -8. So what am I going to do? I need to shift the decimal point, another point that way. So it's going to be 76.5 point north times. So if I make this even bigger, I need to make that even smaller. So it's going to be times 10 to the power 9. So is that engineering notation? Yes, that's engineering notation. Okay, so 0.0000765 is equal to 7.65 times 10 to the power -7 in scientific notation. It is also equal to 76.5 point north times 10 to the power 9 in engineering notation. Okay. Now I'm going to do one more. Let me go to the next one. Let me take that one there, 0.00024. I'm going to take, just make this a bit tinier. There we go. There we go. 0.024. Is it 3? It is 3. Right. Is equal to, right, what? Scientific notation. I need to move the decimal point next to the first whole number. So it will be 2.4. Alright. So I moved it 1, 2, 3, 4. So I made this number 4 places bigger. So I need to make it 4 places smaller. There we go. So 0.00024 is equal to 2.4 times 10 to the power -4 in scientific notation. Okay, is that engineering notation? No, it needs to be in multiples of 3. Okay, so can I move the decimal point this way? No, I can't, because it needs to be a number or 2 followed by a decimal point. So I'm going to say if I make the 24, if I make that bigger, that's going to be, if I make that 10 times bigger, that's going to be 10 times smaller. So it's going to be 10 to the power -5. So it's not going to work. So I need to move it 2 places. So, okay, so I'm going to make it like so. So that's going to be 240 times 10 to the power -6. So if I make this bigger, I make that smaller. Okay, so 0.0024 is equal to 2.4 times 10 to the power -4 in scientific notation, and is equal to 240.0 times 10 to the power -6 in engineering notation. Okay, people, that's my little lesson and note on scientific and engineering notation there. And it says there, convert each ordinary number to scientific notation. Do all of them. And when you're done with all of them, at the bottom it says, then convert each of the above to engineering notation. You can do like I did. You can convert it to scientific and engineering in one go if you want to. You can write on another page and do it yourself. Okay? You don't need to hand it in. You don't need to give it back to me. compare your answer with somebody. I'm not going to give you the answers because the answer you get in the next step. If I give you the answers, it's a bit job done. You won't be able to do the exercise yourself. Okay, so people, that's the exercise for scientific and engineering notation. I'm going back to the exercise there. I'm going back there. Now, the next page says there, convert the following to those units indicated there. Now, people, this is actually the biggies to what we want to get to. Okay, this year, from here onwards, is proper civil engineering stuff. Okay, that's the conversions we want to be doing. Now, when I get to here and I tell it to people, people say, oh yes, okay, I'm not going to worry about this. You do all of that stuff that goes ahead there. You can see that I place them in order, pages 1 to 9. You work through all these pages and you finish all of those before you get to this one over here. Okay, and this one here I'm going to do in the next lesson on conversions, where we're going to get funny units, odd units, and we're going to convert areas, and we're going to convert volumes, and we're going to convert second moments of area to each other. There's 2 steps involved, but I find that over the years, people as a teacher, if you don't get these 2 steps correct in your head, I find students struggle all up to the final year, and they just never convert. And you know what to do? They say 10.33 square meters to square meters. They go I'll take a guess. You know, they guess, and 99% of the time they guess it wrong. They never get it right. Okay, so I'm going to stop there with kilogram, meters and liters, and what we call linear conversions, and these scientific and engineering notations. I'm going to stop there, and I'm going to do the rest of these conversions in the next lesson, and that will be that lesson that will be there. And there's some really special ones which we can get to after that, and then there's some special cases which I'll just talk about and explain, and that's page 9. And that will be the end of conversions and units of measurement. Okay, and once we're done with that, we'll go to the next big things, which will be forces, resultants, vectors, etc., etc. Okay, people, so that's the end of lessons for conversions for that. The next lesson will involve conversions to areas and volumes, and I'll see you in the next lesson.